Okay, so thanks a lot, Karina. So my name is Wole Moses, and I lead growth strategy for federal civilian at Microsoft. And I'm going to quickly set the stage for our session today. So AI is clearly one of the most important technologies of today, and we're already starting to see the impact in the government space. When you think about the amazing AI capabilities that the cloud has enabled, so for example, computer vision, speech recognition, language translation, language understanding, and more, at Microsoft, we're helping to democratize AI in a few key ways. First of all, we offer AI as pre-built services available in the cloud via API calls or even running offline in containers. Secondly, we offer a really powerful machine learning tool set to enable customers to develop their own custom AI models. And then finally, we offer really powerful but easy to use low-code, no-code tool set called the Power Platform to integrate all of these AI capabilities easily into your application. So we're seeing government agencies take advantage of AI in several different ways. For example, to improve citizen experience, especially I'd say through the pandemic and during the pandemic. One example we really saw accelerating is around autonomous chatbots. Government agencies are also using AI to empower employees. In fact, the first of two examples we'll cover today showcases an example of this at the U.S. Department of Agriculture. We'll get to that a little bit later. Transforming government services through AI is something you'll learn about in our second example from the UK. And all of these examples really accrue to optimizing how government functions. So why is this important? Well, according to a study from Deloitte, in the U.S., automation in U.S. Public sector specifically, they estimated that automation can free up to 1.3 billion hours of human labor, which will thus enable those civil servants to do more value-added job functions. 44% projected increase in spending in government AI projects, which I think is an acknowledgement of the value of AI in these scenarios. This represents $16 trillion in spending expected by 2030. And interestingly, 84% of public sector executives talk about privacy and AI quality as issues or challenges which are important for them. And those are actually both key tenets of Microsoft's responsible AI principles. So let me jump into the first presentation, or the first part of our presentation. Below are the names of my co-presenters, and following this session, we'll turn it over to my colleague Dan Haynes from our UK team to talk about some of the work they're doing over there. Okay, so getting into the first example, the first project. So this project took place at U.S. Department of Agriculture, a part of USDA called APHIS, which stands for Animal Plant Health Inspection Service. So APHIS is the component at USDA that's responsible for research, mitigation, and investigation of invasive species, pathogens and diseases, animal-related pathogens and diseases. So think about hoof and mouth disease, swine flu, bird flu, and even COVID, which is recently been found to be transmissible through animals. So this is the core agency within the U.S. That is responsible for the research and investigation and ultimately the mitigation of these pathogens and diseases. So there's a facility off the coast of Long Island, New York called Plum Island, which for the past 70 years has been the central location where this research has taken place. So this is where they do all of the research into all of these animal diseases since the 50s. So a few years ago, USDA decided to move that research facility to Manhattan, Kansas. However, over the course of the past 70 years, they've accumulated 35 million pages of handwritten research. So these scientists and researchers who've been conducting this research on Plum Island over these 70 years typically capture the notes related to their research in research notebooks, and the majority of it is handwritten notes. And so USDA came to us a few years back, letting us know about this issue they had around the closure of Plum Island and the need to digitize the handwritten notes, but then most importantly, to use AI to understand what's written in those notes, in the digital versions of those, even handwritten notes. And so this was a big problem that they came to us with. And so the Microsoft team partnered with one of our key system integrator partners called FedScale, as well as another company called Cygen, to tackle this problem. So I'm going to turn it over to my colleague, Erik, who's going to talk through the solution and the process for getting to that solution.
Thanks, Wole. My name's Erik Munson. I'm one of the FastTrack for Azure program managers on the federal space. I'm here to talk to you about kind of the project scope for this particular project. Initially, what we had done is we took the opportunity to kind of demonstrate to the customer, USDA in this case, a couple of off-the-shelf capabilities that we had using the JFK file demos and also the knowledge mining solution accelerator. Wole, if I could have you advance one slide, please. And in doing so, we were able to take OCR content and put that into Azure so that we could bring the resources that Azure has to bear on that data and also make it more publicly available to folks that weren't necessarily on the island. That was a big problem that they were trying to solve, making this data more accessible to the scientists from any location instead of having to have them go out, which was a highly controlled environment. The other component that we talked about in there was effectively the impact that this had from resulting business impact that we had for the customer. And one of the things that we were doing there is we were taking the public GitHub repo content and actually weaving that into the solution. So we took the initial demonstration that we did in roughly about a week to show them what the capabilities were using just generic data. And then we kind of matured that using the GitHub repos that were publicly available for both commercial and gov. And then took that information, started weaving together the solution that would allow them to act on their data and actually OCR that data, get it up into Azure, and then bring the capabilities of our cloud platform to bear on it. One of the things that we discovered along the way in this solutioning, which is common to US federal government customers, is the ability to limit the public endpoints that are associated with a particular solution. In the commercial space, that's less of a problem, but in the government space, that's a common practice. And we were able to overcome that challenge by using the capabilities of private link service and private endpoints to allow our PaaS services to continue to operate, even though we weren't exposing them publicly to the internet. So that was really a key evolution to the solution. And then what I'd like to talk about is what's next for the customer. Our intention is to take the IP that we developed throughout this process and actually publish that back into the GitHub repos so that they can be more accessible to partners as well as other solution providers that are looking to do similar capabilities on our platform for other customers. And I will tell you that within USDA, there are many other bureaus that have a similar challenge where they're trying to digitize and commoditize a number of their capabilities so that they can bring that information to bear across the organization and have more eyes and make better intelligent decisions based upon the information that's presented in the cloud. And with that, I'm going to turn it over to one of my colleagues, Marck Vaisman, who's going to talk about the technical scope of the project.
Thank you, Erik. Good evening, everyone. My name is Marck Vaisman. I am a cloud solutions architect and a data scientist here at Microsoft Federal Team. I work across many civilian customers, and I've been the primary technical lead on implementing this project, working with our internal teams and our partners and our customers. So what I'm going to show you here is really just an overall architecture, just to tell you how the solution works. This is based on as Erik mentioned, right? We have a couple of solution accelerators, and we are working on making some of this IP available there. But we will post two links. One is to a solution accelerator for knowledge mining and cognitive search, which you can deploy in Azure. And then we have a federalized version of it, which you can deploy in Azure Government, which already takes into account some of the private endpoints. So what you're seeing here, this is, again, the overall solution. So there are many moving parts. First of all, we had to integrate with this third-party tool from Cygen. So the folks at Plum Island were using a solution from Cygen, or two solutions from Cygen. One is called SciSafe, and the other is called SciCapture. SciSafe is like a document metadata archive of sorts, and then SciCapture is a workflow tool to for scanning. So they're using those two tools on site for scanning a lot of these documents. So they're scanning, as well, I said, millions of pages. These are all a lot of laboratory notebooks and just research activity, and to make that data available. So what you see here is the way this works is that happens on the island, right? And they have these tools deployed on the island on premises. Now, it just so happens that the backend for the SciSafe tool is actually a SQL database, which actually is on Azure already. And then when you actually scan the file on premises, it gets saved locally. So there is a workflow that actually moves that data, or that PDF file from there to the cloud. Once it's in the cloud, so we developed a Azure Data Factory pipeline, which basically merges these two things together, because there is a PDF file, and then there's an associated metadata record that is separate from this file. So what we developed as part of the overall solution is a way to do this all within, using custom skills, using the knowledge mining and cognitive search framework, with custom skills to do the document processing. So the document processing consists of 3 separate steps. The first one is a reduction of the PDF file size. And the reason for that is because a lot of these documents are really, really big, because these documents are scanned at archival, meeting archival requirements from NIST. So these are high-res PDF files, which can be, some of these could be in the order of probably a couple of gigabytes. And running those files through OCR can be a little bit challenging. So what we developed was a workflow that the first thing it does is once a file gets uploaded, that the PDF file the file size gets reduced. And it gets reduced probably about to 1/3 of the size. And that reduced file is the one that we use to OCR. There is no degradation. It's just that we're working with this reduced file size. We're not touching the original file size, the original file. The second piece is also merging the metadata into the document itself. So the metadata is really outside of the PDF file. It's not inside the PDF file. And the metadata consists of obviously like the author, the lab, a bunch of other metadata, and there are different metadata fields or metadata structures for different labs within the island. So we had to come up with a solution that accounts for all of these things. So ultimately, all of these things end up, and then the third piece is to OCR these documents using our custom vision, computer vision, behind a private endpoint. But because it's behind a private endpoint, you have to run that as a custom skill, not an out-of-the-box skill that the framework provides. So once all the files go through, they get converted to JSON, and then that gets indexed, and that's what becomes part of what you're going to see in the demo. The file with all the metadata and also all the OCR text that we would present as part of the search engine. So the process starts on island, then it moves to the cloud, and then everything lives in the cloud. And then there is a client that is, the front end is also cloud-based, but obviously the idea is that for the researchers to be able to access all this information from the island. Next slide, please. So, Erik mentioned some of the challenges and some of the requirements. So we deployed this in Azure Government, right? And so, like I mentioned, some of the challenges that we ran into, well, not a specific challenge, but obviously we were looking for a way, or the customer was looking for a way to OCR mostly handwritten documents. So that's why the first thing that we showed them was our OCR capabilities, which work really, really well. Like I mentioned, the fact that we have very large documents, we had to find a way to make that fit the workflow. So we developed a custom skill that an Azure function that runs as a custom skill, and that calls the API, the reduced file size calls the API, gets sent to the API, gets the response, and then all that stuff gets indexed. The third challenge here was really this idea of combining not really the idea, but obviously you have a PDF file, but the PDF file itself doesn't have the metadata that you also want to index, which is, like I said, things like the author, the date, the lab, or all these sorts of additional fields. So when you use our knowledge mining solution, the cracking of the document really extracts the contents from the document. It doesn't extract anything external. But the way to make that work is we actually added that metadata into the blob itself. So once the PDF file is on Azure in blob storage, we created metadata fields in the blob from the metadata in the document. The fourth point was what Erik mentioned about this idea of being behind private endpoints, which we've addressed. There was a lot of networking work done in the back end such that everything is behind a private endpoint, and DNS gets forwarded to the right place. And then the fifth thing was really, really key in this project was the ability to deliver this that is as low maintenance and automated as possible. And that was done by wrapping all of this within an Azure Data Factory custom pipeline, which really orchestrates everything. So when the customer needs to add more documents or more cabinets, as they call them, documents with different metadata fields, all they need to do is just, and Frank will show that as we move into the demo, is just add a new track in the flow, and then that kicks off everything. So it's really a kind of turnkey handoff over to the customer. And with that, I'll turn it over to my colleagues Frank and Shirley, so that they're going to do a quick demo.
Thank you, Mark. Hello, everyone. I'm just going to introduce myself real quick and Frank. My name is Shirley MacKay and Frank Garofalo. We're on the FastTrack team. I specialize on the development side, so the custom skills that Mark described here, that's those kind of things that I worked on. Frank worked on this, but he specializes in the data AI side, so the Azure Data Factory and cognitive services. So we've kind of bridged those two skill sets here. And then, so I'm going to go ahead and turn it over to Frank to demo the solution.
Thank you, Shirley. Like Shirley and everyone else before me had said, this was a joint team effort, and everyone had a lot to contribute to it. The key thing to kind of highlight is the solution is completely secure behind private endpoints, meaning the data cannot be accessed outside of the virtual network that's configured to communicate. So this high-level architecture kind of shows the fact that all of the Azure services are communicating with each other over private endpoints and VNet integrations. So the private endpoint is the connection into the service, and then the connection out to the private endpoint from, let's say, the cognitive search service to the data stored in blob. It uses a shared data service over a private endpoint. So cognitive search reaches into the storage over a private endpoint and OCRs that PDF. And part of that process is like what Shirley had brought up around the custom functions. When the PDF is dropped into a raw drop, it triggers an event hub action that calls a function to use some OSS software to reduce the PDF size, and then moves the file into this optimized directory. From the optimized directory, we run some data factory pipelines to add the custom metadata and move the process files into a process directory so they don't get picked back up and re-ran through the process. But just on a high level, you can see here in our optimized directory, we're at 940 kilobytes. And if I go properties on the file itself, we can see the custom metadata associated with that PDF. Now, this metadata is driven from the barcode, which has a record inside the SQL database. So that way, when we do the data factory lookup to assign the metadata, data factory parses the barcode of the file name and writes to the correct file. Now, if we take a look at a process file, we can see that it's quite a bit larger. It's 3.2 megabytes. And then if I look at the properties of that file in my storage account, there's no metadata. I just wanted to show that at a high level. And all of the services involved, you can see all of the private endpoints that had to be configured to have each service talk privately and not be exposed to public routing. And the reason I'm able to access this right now is I have configured in my demo environment a VPN Gateway, so I'm actually configuring and tying it into the VNet itself. And we take a look at the data factory job that runs. Part of this pipeline is to use some REST API calls and then some built-in Dynamics SQL to leverage the way the COTS application, the PSI, stores the metadata in their database. We wanted to create something that was kind of low to zero touch for the customer themselves. So if we were to go look at the query that's run to identify which PDFs need to be metadataized, essentially. So we're writing the metadata to that file in the custom blob storage. We have dynamic SQL that actually reads from the schema of the COTS app itself and then generates the output to map it to the next stage. And the next stage does some for each loops. And the customer, when they add a new cabinet into their application, they just copy these 3 tasks in Data Factory, or they'll create a whole nother Data Factory and call with a sub Data Factory process. But if we were to go look into that task, what ends up happening is we've passed that we set the barcode for what was passed through that SQL query. We check to see if that file actually exists because there could be a file that is in the database but hasn't been written to the storage account yet. So when we do that, we need to get a little bit of information and we do a switch. So if the file doesn't exist, it doesn't try to write custom metadata to that PDF. And if it does exist, it updates the file. And then it checks to see if the raw metadata file is existing in the environment. If the raw file is in the raw dropped, and then it goes through the process and lands back into the raw directory. Shirley, I think there's some questions. I'm going to try to go fast through this, and I can always come back to other areas. So let me hop over. So one thing to make note of in cognitive search, when you turn on private endpoint in the government cloud, you actually have to disable the configuration of the cognitive services from the portal. So all access and work within cognitive search itself has to be done via API calls or ARM templates or PowerShell. So we try to generate and build out some sample API calls using PowerShell, so the customer can actually just run through a series of PowerShell helpers and just update the content of their indexers and custom skill sets. So we have a base index. So if they end up finding they need to add a new metadata record to the index, they can come in and copy the JSON object and add that new column like it's a new column in a database almost, and then update the indexer. And then if you can see here, we have this custom skill set that Shirley and Mark were referencing. And this custom skill set actually calls a function. This endpoint is a function, and then the function calls the Vision API over a private endpoint. That's how it works in a nutshell. And then a closer look at the SQL that's dynamic. Just wanted to reference that so you can see it. So what ends up happening is the customer passes in the cabinet, a time frame, and then it generates the values to pass in for the custom metadata. And the reason this was tough for them is because the way the application stores the metadata is actually not in a columnar format. It's just a general list, and there was some mapping based on column names. So when a new index is added within their COTS application, it just adds a new row in the record and assigns the name as the value for that record. So we had to do some kind of custom mapping to map the name to the index, which is associated with the cabinet and the PDF. Now, to get into the app itself, we did 2 versions of the app. One was the custom accelerator that was already talked about, just using the GitHub example, and then making it look more like the customer's site by adding their logo, and we can pass in any kind of value. So maybe we wanted to pass in some type of animal flu or fever to search for any PDFs that may be potentially associated with bovine fever. And you can see here we found one for bovine serum, and we can click into that PDF, and then we can do some further drilling down of that PDF to find out some more information if this was actually the notebook that I wanted to scan. So now I can use a search inside of the search of the document to try to find more information about that specific phrase, right? So I wanted to search for test methods, and if I wanted to see, okay, what's about test methods, I can click here, and now I get to see all of the transcribed data from the PDF. And we can also see the metadata about information around what the document was, who wrote the document. So if I needed to go reproduce or print off the PDF from the storage account, I have all that metadata information and it's easily accessible. The other option that we wanted to show was using the JFK demos. So the JFK demos is a little bit different in the sense of like how it's written and how that UI works. So part of that app is it uses React, and React gives us a little bit more interactive content to navigate the search term with the actual image itself. So the solution accelerator on the Gov side for the knowledge mining doesn't actually do the mapping to the image where the JFK does. So you can see here, I searched this term, and if I drill into the document, it actually is highlighting that handwritten text. Now, if we go into that PDF itself, and I can do searches within here as well for handwritten text or that term. Whoops. So you can see here, my screen's getting a little laggy. So you can see here the actual handwritten text has been OCR'd and transcribed into searchable terms, which has been passed into cognitive search itself, which is pretty cool. Now, the benefit of the JFK sample is when I find a term or word that's been searched, I want to see what page it is on the PDF. We have that actual mapping from JFK to the PDF value itself. So in a nutshell, that's our demo, and I'm going to hand it over to I believe Daniel's up next, Daniel Haynes.